In this video, we will be looking at the triangle sum. But to be honest, the majority of the video is not going to be about that, but rather how to classify triangles by their sides and their angles. With respect to classifying triangles by their sides, we're going to be looking at how many of the sides are congruent. A scalene triangle is going to have no congruent sides. All the sides are different lengths there. If you have at least two congruent sides, you're going to be able to call that an isosceles triangle. This is typically the picture that we have, except that I've got it rotated to the side here. A scalene triangle is going to have no congruent sides, which would mean that none of the sides are the same length. An isosceles triangle has at least two congruent sides. Notice that it says at least two congruent sides. So technically, if all three sides are congruent, then we would call it an isosceles. However, if all three sides are congruent, a better name for that would be equilateral, and it's a little bit more descriptive from there. The classification by angles is going to be based more on the size of the angles than it will be the number of congruent angles. However, if you do have three congruent angles, we can refer to that as an equal angular triangle. All right, an acute triangle is going to have three acute angles in there. You'll have three acute angles, they'll all measure less than 90 degrees. If you do have one 90-degree angle, that will be a right triangle. It is impossible to have more than one right angle because if you did, it would be impossible to close that triangle. If you have one angle that is greater than 90 degrees, then you would have an obtuse triangle. Again, it would be impossible to have more than one because if you did, you would not be able to close that figure. All right, coming back to the equal angular triangle, you're going to notice that all of these angles are also acute. All right, recall that the triangle sum is 180 degrees, which means that if you divided 180 by 3, you do get 60 degrees in all of the corners. So technically, an equal angular triangle is an acute triangle. However, if we refer to it as equal angular, it gives us a bit more information, which is that all the angles would be 60 degrees. For example 1, we have been provided a triangle that has been plotted in our coordinate system, and we're asked to do two things here, which is to classify by the sides and classify by the angles. All right, classification by sides. What we're looking for is whether or not we have any congruent sides. Now, clearly we have one side that is shorter than the others, which means that we do not have an equilateral triangle. However, the other two sides that we have here can appear to be pretty close in length to each other, and sometimes it gets a little bit confusing because we've got these grids in the background, and that can kind of make everything look slightly different. All right, so a neat trick that I can show you here, I'm going to take a piece of paper and I'm going to line it up with one of the sides. Let's just go with OQ. Okay, I'm going to line it up here and I'm going to mark off the length of OQ, and then I'm going to take that, go over here and match it up with PQ. All right, and when I do that, I'm going to notice it appears as though that segment is just a little bit longer than OQ. Okay, so visually, I believe now that this might be scalene, but if the picture is not drawn to scale, if these aren't actually true squares that we have here, that could be a little bit misleading. So now what we're going to do is take a look at the possible calculations that we could do. All right, so think back. How would we really know the length of these two things? We could use the distance formula, right? We can use the distance formula to calculate the distance between 2 points. Of course, the distance formula is based in Pythagorean theorem. So I'm going to look at OQ as being a hypotenuse with leg lengths that would be here and here. The bottom leg length is going to be 6 units. That takes us from 0 to 6, so that would be worth 6. The vertical is going to be 3. All right, so off to the side here, I'm going to take a look at 6 squared plus 3 squared, which is going to be 36 plus 9, which will give us 45. All right, so then the length of that would be the square root of 45, but I'm going to go ahead and hold off there and not really calculate it. All right, from P to Q, the horizontal change is going to be 1 and then 6, which gives us 7, so we'll have 7 squared. The vertical change is going to be 1, all right, so we have 1 squared. 7 squared plus 1 squared is going to be equal to 50, which means that PQ is the square root of 50. And without typing these two things into the calculator, I can already verify that this is going to be the greater one here. That means that PQ is in fact just a teeny bit larger than what we had for OQ. Therefore, the type of triangle that we have based on side lengths would be scalene. We'd have a scalene triangle. All right, to classify this by the angle measures, we need to think about what the sizes of the angles are. All right, I believe if we look at this angle over here at Q, we can tell that that one is clearly smaller than the other ones, and it's definitely an acute angle measurement. Looking at this one right here, I think we can also identify that one as being an acute angle measurement. However, the one that we have over here at the origin, that one becomes a bit of a debate. It visually looks like it could be a right angle. It looks like we could have two perpendicular sides here. However, there's a chance that it could be slightly acute or slightly obtuse. All right, so like when I looked at the side lengths, what I'm gonna do here is a little trick with a piece of paper. All right, so I have a piece of paper that should have right angles on it, and if I place that corner in there, you're gonna notice that it looks like it matches up, like it really could be a right angle. However, again, if the grid is not drawn perfect, if all these little boxes aren't squares, that could be misleading. Okay, it might not actually be a right angle. All right, so how are we gonna verify that? You can do this by two methods. One, we could think about Pythagorean theorem, because Pythagorean theorem only works if you have a right triangle. Okay, so if I did Pythagorean theorem with this, and it works, we would know that we do have a right triangle. Now here's some things that we've already figured out. Be thinking a squared plus b squared equals c squared. And we have sort of already figured out b squared and c squared. We sort of already figured that out. Okay, so a squared plus b squared equals c squared. All right, so b would be the square root of 45. Okay, b would be equal to the square root of 45, which means that if we took the square root of 45 and we squared it, we would get back 45. Likewise, the c value would be the square root of 50, which means that if we were to square the square root of 50, we would get back 50. All right, so for the little side here, if we treat that as a hypotenuse to get its length, we would have a 1 by 2. You'd have a 1 by 2, so 1 squared plus 2 squared, which would be equal to 5. Okay, so we would have the square root of 5 is that length. But if you take the square root of 5 and you square it, you're going to end up with 5. And this checks out. 5 plus 45 is 50. That means that we do have a right triangle. We do have a right triangle. As an alternative to answering that question, what we could also do is look at the slopes. We could look at the slopes of the lines that intersect with each other. All right, the one we were just looking at, or the short one, that has a vertical change of 2 and a horizontal of 1. So the slope there is 2 over 1, except that it is going in a downward direction, so that would be negative. It would be a negative 2 over 1. The other segment is 6 by 3, which means that it has a rise of 3 and a run of 6. That reduces down to 1/2. And we see that 1/2 is the opposite reciprocal of negative 2, which would also confirm that this is a right angle. All right, so we have a scalene right triangle. All right, so now let's look at the triangle sum theorem. The sum of the interior angles of a triangle is 180 degrees. That is always true, no matter what triangle you draw. When you add up the angle measures of all three angles, you do end up with 180 degrees. Example 2. Find the measures of the acute angles of the right triangle. All right, so we have a right triangle here. That means that this angle measurement is 90 degrees. Okay, and if all of them are going to add up to 180, you could go ahead and subtract. You could go ahead and subtract the 90 degrees that we know, which leaves us with 90. Okay, so these are actually going to be complements. Those two add up to 90. All right, and if they do add up to 90, we can take the expressions that we have for them. We can take those expressions and set that equal, not to 180. We can set those equal to 90 degrees. We can set them equal to 90. We can go ahead and group like terms here, which will give us 3x. We got 3x minus 6 is equal to 90. Go ahead and add the 6 over. We get 96. And divide by 3, we get x is 32. We get x is 32. That would not be the answer to the question. What we needed to do was figure out the measures of the acute angles. So we're going to plug that in. 2 times 32 is going to give us 64. The complement to 64 is going to be 26. So let's see if that works out. Take 32, plug that into the x. 32 minus 6 is 26 degrees. All right, so those would be our answers.
Later, Brah.